Hey folks, this is lesson 14? Dear Lord, is that right? 14? My gosh. Talking about alternate interior angles with transversal. You'll understand what that means in a moment. I need to change that. Oh, well, what are you going to do? Okay, so we're going to name the angle that is noted with a 30-degree angle measure of the figure. So it's this angle right here. So when you're naming an angle and you have kind of like 3 points that are on the lines in the figure, or the line segments, you're going to use those 3 to represent the angle. The point kind of at the vertex of the angle you're measuring is going to go in the center. And you're going to do this. You're going to say this little angle symbol, right? You can do like that right there to differentiate it from an L, and you could go J, G, F. Or you could do F, G, J. As long as the G's in the middle, that's really the thing that matters the most right there, right? So JGF is referring to only this angle right here. Let me get a highlighter so we can highlight it. If I can find a highlighter, gosh, I would love it if I could find a highlighter right now. What are you gonna do? I find a highlighter. Okay. Anyway, so that's angle JGF. Now, when it says angle JGH, right? JGH, and that's G's in the middle, right? And the J and the H tell you that it's going to be this particular angle right here. Explain or show your reasoning. Well, when I look at this, I think of it as a straight line right here, and I know that a straight line is basically a 180-degree angle measurement because it's like half. It's a bad circle, but it's half a circle, right? So I know that this one and this one are going to add up to 180. So what I'm going to do is I'm going to take this 30 and I'm going to subtract it from 180, right? So 180 minus 30, 0, 5, and then 1. So that's 150. Okay, so explain or show your reasoning equals 150 degrees. Okay, so that's when I show my reasoning. It's right there. If I explained it, I would say something like, well, I know it's a straight line, so 30 plus 150 is equal to that 180. Find and label a second 30-degree angle in the diagram, and then find and label an angle congruent to angle JGH. So when I look here, I've got a 30 degree. I know this is 150 degree. I've got 2 more angles that I haven't really talked about yet. Just looking at them, I can see that this one is acute and this one is obtuse. If I kind of switch my thinking and I start thinking of this as another straight line here, then I know that this 150 plus this are going to add up to 180. So that's going to be a 30 degree. Find and label an angle congruent to angle JGH. Sorry if that was off the grid. I chose this, basically this straight line here, 150 plus 30 will equal that 180 right there. I can look at this line right here, and I can see that this 30 plus this 150 will add up to 180, right? And you'll notice that we've got these angles are definitely across from each other. They're the same, and then these angles that are across from each other are the same. So then this actually leads us into our some vocab. Okay, we've got supplementary angles. These are angles that add up to 180. So on there, yeah, add up to 180 degrees. Can be next to each other. But not necessarily. Not all the time. Okay. Okay. So like these angles, that 30 and that 150 are next to each other. So that 30 plus 150 is equal to that 180 right there. Okay. So supplementary angles right there, just angles that add up to 180. Typically, they're going to be next to each other, but not necessarily. Okay. Vertical angles are angles that are across from each other. They are congruent, meaning the same measurement, right? So when I take a look at this figure, I've got these 2 that are across from each other, and I've got these 2 that are across from each other. And the ones that are across from each other are the same measurement, right? So if we kind of just real quick I'm going to say that this one is, whatever, say 70 degrees here. The one across from it is going to be 70 degrees. Okay. Yeah, so there you go. Supplementary angles, vertical angles. And then traversals, or transversal, golly. Transversal is a line that cuts across, intersects, parallel lines. Usually it's two, but it doesn't have to just be two. You can have more, right? So if I have a set of parallel lines here, and then I have a transversal, and I label it for whatever reason K, this is the transversal. Can you see that? Maybe, maybe not. Let's see, sorry. I'm off, right? So you have parallel lines, the line that cuts across them, that's our transversal, okay? And that's going to be relevant on the next problem, and we have parallel lines cut by a transversal, okay? So we have lines A, C, and DF are parallel. So A, C, and DF parallel, meaning they don't intersect, they'll never touch. They're cut by transversal HJ. So this is our transversal right here. Okay, real quick, label that. Okay, can you find the measures of all the other angles? The only one we know so far is 63. Now, I'm going to, based on what I just figured out, I know that vertical angles are the same. So this is 60 degree right here. And I know that like this one right next to it is going to add up to 180. So I'm going to say, to figure that out, I'm just going to say 180 minus 63, right? I'm going to have to borrow here. So that's 10 minus 3 is 7. Why did I write that directly on the line there? 7, and then 7 minus 6 is 1, and I bring down that 1. So I know that these are 117 degrees. Okay. Now, you might be thinking like, well, how do I get from these 4 to these 4? I don't know what I'm doing, Mr. Wishart. Golly, why did you teach us how to do this? Oh, look, I have tracing paper. Okay. So kind of just draw those right here. Oh, one thing that I want you to know, guys. This circle right here just is a reminder that if I add all of these up, I'm going to get to 360. Okay, so like this, that is kind of where these degrees come from. So I've got this one right here. I'm going to take this and I'm going to just translate it directly up. And I can see that they are pretty much congruent right there. Those are going to be the same measurements, right? So all I'm doing is taking this set of angles, shifting it up, translating it up, and I can see that the ones that kind of look the same, like this one at 63, matches directly up to that one right there. So this one's going to be 63. This one's going to be 63. This one's going to be 117 because it matches to this angle right here. And then this one's going to be 117, right? So that's how we do it, right? We find supplementary angles by subtracting from 180 to get that 117. Vertical angles are congruent, and then you can kind of just translate. You don't actually have to do the translation with tracing paper once you kind of understand this, but as long as your lines are parallel, that this is going to be how to figure out these angles, right? Because it's just going to match up to the angles on the corresponding angle, kind of on the other side of the transversal there, okay? Find the measures of the 4 angles at point B right here. So I have none here, but I do have this 34 degrees. Now, I'm going to do the exact same thing, okay? It's telling me that AC and DF are parallel lines. So I can count on these angles being the same. So I know this is 34, and as I translate it, I know that this angle right here is also going to be 34 degrees, okay? So I can just write that right there. And then based on these being vertical angles, I know that's going to be 34. And then I got to figure out these two, but I know that they're right next to each other, so they're supplementary. So I can say 180 minus 34. That's going to be 10. I got to borrow here. 10 minus 4 is 6. 7 minus 3 is 4. So I get to 146. So that's 146, and then the vertical across from it is 146. So that's how you figure this out, guys. That's directly related to translations and other transformations as we shift things around to figure out these angle measurements. There you go.